Hello, everyone. Welcome back. Today, I am going to be talking all about finding the equation of a line from data. So, we're going to begin talking about, for this entire unit, the equation of a line, graphing, all that kind of stuff. So, that's what this unit is all about, is that equation for a line. And this is something that we're going to be building on to do equations for all different degrees of polynomials in future courses. So in this course, we're just going to stick to linear equations and lines. In future math courses, we will build on this. So this is very important. So here it says, finding the equation of a line from data by examining a table of values for linear relation, right? A linear relation is what? It's a relation that produces a straight line when graphed. So whenever you see linear relation, just know that they're referring to a line essentially. An equation for the line can be found. So all lines follow the same pattern. All linear equations follow this pattern. Y equals to mx plus b, where m is the slope and b is the y-intercept. So what is the y-intercept? The y-intercept is when x equals 0, what is y equal to, right? That's our y-intercept. And the x-intercept is the opposite. The x-intercept is when y equals to 0, what is x? So what are these things broadly? Well, overall in general, y equals to b, right? That's the y-intercept, right? Because if x is 0, we have 0 times m, which is just 0, plus b. So therefore y equals b is the y-intercept. As for the x-intercept, let's say y was 0, it would be negative b over m, right? If we rearrange this equation, y equals mx plus b, and we put y as 0, we subtract b from both sides and divide by m, this is the result, right? And so the x-intercept can be found in this manner as well. Now, what about graphically, right? Graphically, the y-intercept is the point where the line touches the y-axis. And then the x-intercept is the point where the line touches the x-axis. Good. So here for question 1, they want us to examine the following graphs and determine the y-intercept and the x-intercept. So how can we know determining from our graphs? Well, as we know, the y-intercept is the point where the line touches the y-axis, right? And the x-intercept is the point where the line touches the x-axis. So let's look at the x-axis first. Where does this touch our x-axis? It touches it at -4, 0. So the x-intercept is -4, 0. And what about the y-intercept, right? It touches at 2. So therefore the point is 0, 2. Good. Let's try this next one. What is the x-intercept? Well, it looks like this line crosses the x-axis right here at 0, 5. Or sorry, at 5, 0 rather. My mistake there. And then what about here? We have 0, -3 is where it touches the y-axis. So all we must do to find the x-intercept and the y-intercept is we need to look at where does the line touch the x-axis for the x-intercept and where does the line touch the y-axis for the y-intercept, right? Because all across the y-axis, x is 0, and all across the x-axis, y is 0, right? If we're just going across the x-axis, we're just going left or right. We're not going up and down, so we're not using that second dimension there. And same with the y-axis. If we're just going up and down, but we're not going left and right at all, we're just staying on that y-axis line itself, then we're not really we're not really branching out past that. We're just staying in that one spot, and we're not using that other dimension there. So yeah, so long story short, location of the y-intercept here is 0, 2, and location of it here is 0, -3, as we already stated. Now note at the y-intercept, the x-coordinate is always 0, right? And same goes for the x-intercept as well. The y-coordinate is always 0, right? That kind of goes back to the definitions, is that for y-intercept, if x is 0, we need to find y, and then vice versa, right? And so that's a huge note, a huge key takeaway here is that at the x-intercept, the y coordinate is always 0, and at the y-intercept, the x-coordinate is always 0, no exceptions. Unlike French, which has a lot of exceptions. Anyway, let's move on to number 2. A linear relation has the following xy points: -5, -6, -0, -4, 5, -2, 10, 0, and 15, 2. So I'm going to put these into here. So here we have -5 and 0, or sorry, it's -6 rather. Then we have -0, which is just 0, -4. We have 5, -2, 10, 0, and 15, 2. So those are our points. Now, how do we find the slope? So the slope, there's a few ways we can describe the slope. The slope is equal to rise over run is one common equation. Or another common one when we have the points and not a graph is that delta y is over delta x is our slope. Now, what does delta y and delta x mean? By the way, this triangle, this is delta, right? This is a Greek letter called delta. It's not really a triangle. So this is delta y over delta x. So what is this in simpler terms? This means the change in y over the change in x. Okay? Or another way we can put it is if we have any 2 points on the line, we can find it by taking y2 minus y1 over x2 minus x1 with any 2 points. Now here we were given 5, so we kind of have our pickings of which points we'd like to use, but no matter which 2 points we choose, we will get the same slope, right? Because this is a linear relation, which means all these points are on a line, which means the slope is consistent. The change in y at a certain point over the change in x at a certain point is going to be the same all throughout. Now, this is not true of all relations, but this is true of all linear relations. So all the relations we'll be looking at in this course specifically, it is true that the slope is always the same. Okay, so let's find the slope now. I'm going to choose 2 points. Let's do just the first two, -5, -6, and 0, -4. So let's say here we have x1 and y1, right? Because this is number 1. And then for 2, we have x2 and y2, right? Or so there we go. So I just labeled the points. So it doesn't matter which one you choose as number 1 and which one you choose as number 2, as long as you're consistent. So this entire coordinate either is 1 or it's 2. We can't mix and match. Okay, so do keep that in mind. We can't mix and match or we will get the wrong answer. Okay, so what's y2 in this scenario? It's -4 minus y1, which is -6, and that's over x2, which is 0 minus x1. Now, one thing to keep in mind, we have negative numbers here. So when we put the subtracted sign and then the negative number sign, those are two separate signs. We don't just write the subtract sign once. I see a lot of students make this mistake where they will write the subtract sign differently. Okay. So with that all said, this is actually -4 plus 6 and then 0 plus 5. I often see students make the mistake of being like, oh, -4, and then there's already a minus there, so just 1 minus 6. No, we want to make sure that we do include both, otherwise we won't get the correct answer. So keeping in mind that if we're subtracting a negative number, we're really adding, right? Two subtraction signs right next to each other like this really means we add, right? Two negatives make a positive, so to speak. So on the top, we have -4 plus 6, which is 2 On the bottom, we have 5. So therefore, our slope is 2 over 5. So therefore, the slope of the relation is 2/5. And the y-intercept is what? Well, the y-intercept is the value for which when x is 0, y is what? It would be -4, because one of the points they gave us was that when x is 0, y is 4, right? This point right here they gave us. Good. Now then, the equation of the relation is what? Well, as we said before, the equation of all lines is y equals mx plus b, where m is the slope and b is the y-intercept. So therefore, the answer is y equals 2/5 x minus 4, right? Good. Okay, let's do some more examples. Using the same method as above, find the equation of each linear relation in the table below. So what is our method for doing that going to be? Well, it's going to be to find the slope first and then to find the y-intercept. Now, to find the y-intercept, it might already be given to us, right? So in A and B, it's actually already given to us in the equation. In C, it is not, but I will go through when we actually get to C, I will go through how we can actually find that one. So if you're feeling confident about this and you want to skip ahead to C to figure out how we'll figure it out when it's not given to us, go for it. But if not, please do, stick around, see both in the next couple examples as well is good too. Okay, so for A, first thing I need to do is find the slope. So I'm going to use the first two points to find the slope. So what's the change in y? Well, that will be 3 minus -3, and the change in x is going to be -1 minus -2. So that's going to be 3 plus 3 over -1 plus 2, which is going to be 6 over 1. So therefore, the slope is 6 for this first equation. Now, what's the y-intercept? Well, it's going to be 9 because we have this point here of 0, 9. And we know that the y-intercept is the point at which when x is 0, what is y, right? So, therefore, y is going to equal to 6x plus 9. So notice that this is the same as y equals mx plus b, but I replaced m with 6 because we solved for that. And I also replaced b with 9 because I recognized from the points on this graph, or in this table, it's not really a graph, I guess, it's a table in this case. From the points on this table, we have the point 0, 9. So that means that 9 would be our y-intercept, right? Because wherever x is 0, whatever the y value is, gives us that intercept. Let's try B next. So let's find the slope first. That's going to be the change in y, delta y over delta x. So what is delta y? Well, let's see, 15 minus 18 would be the change in y. What about the change in x? That's going to be 0 minus -2. So let's see, 15 minus 18 is -3. And that's over 0 minus -2, which is +2. So -3 over 2, or -1.5, is our slope here. Now, what is our y-intercept? Well, we have the point here, 0, 15. So we know that if x is 0, y is 15, right? So that's our intercept, and that's our b value as well. And so we'll just put plus 15 right there. Very good. All right, let's try C, and this is going to be the same method to find M. So let's do that first. M is going to be equal to delta y, which is going to be 0 minus -4 if we're using these first 2 points again. And delta x would be 4 minus 2. So we're going to end up with 4 over 2, which is 2 as our slope. Now you might be thinking, well, okay, 2 is our slope, but what's our y-intercept? We know our x-intercept because we have the point 40, but we don't actually have the y-intercept. So how do we find it? Well, we know the slope is 2, right? We know that that means every time that we move over by 1x, we go down 2. And we can clearly see that. We have the point 2, -4, then we go up 2, and, for x, so we go right 2 and up 4. and then we go right another 2, up another 4, and so on, right? We keep using this rate. So what if we went down 2 to 0? What if we went down 2 to 0? What would happen? Well, we will go down 4, right? If we go down 1 with respect to x, we go to the left 1, we go down in this situation, right? So we're going to go going down to -8 here to follow this pattern. So therefore, our b value would be -8, right? So keep that in mind that if it's not given to you, we can use the slope and kind of reverse engineer and figure it out. Another way we could do this as well that also works great is we could also just take this equation y equals 2x minus, or plus b, and then plug in any point we have because we already have lots of points here, and then solve to get -8. So I'm going to also show that way, as that way might resonate with more people actually. So let's do that. Y equals 2x plus b. So we don't know what b is yet. We're pretending we don't actually know it's -8. We're going to plug in some values here, some point, and we're going to find b. So I'm going to plug in this point for 0 just because I think it's easiest. So that means 0 is equal to 2 times 4 plus b, which means 0 equals 8 plus b, which means b equals to -8, right? So there we go. We found the same answer this method. So we get y equals 2x minus 8 as our equation. Now, let's say you don't want to use 0 for some reason. You can use any point, right? This is a great technique to use as long as you have a point and the slope. You're able to find the full equation. You're able to find the b value just from that, just from a point and the slope. Or if you have 2 points, you're also able to do this because if you have 2 points, you're able to find the slope from those 2 points. And then you're able to use that slope you found with one of those points to find the b value, right? So if you're given either the slope and 1 point, or you're given any 2 points on the line, that is enough information to give you the full equation. Now, if you're just given 1 point, that is not enough information to find the full equation. And the reason being for that is that if you have 1 point, there's so many different lines that point could be a part of, right? Is the point, is the line sloping up or down? Well, we don't know. We just know that a certain point is on the line, which doesn't tell us that. But as soon as we have a second point and then we connect the dots and, extend it, we can clearly see which direction it's going. We can clearly see if it's sloping upward or downward. We can see by how much. It's a lot easier, right? So that's a really key important point that I wanted to get across there. All right, next time we're going to continue. Actually, let's continue here with another example. It says here the table below represents the relationship between the cost and repair time at an appliance store. Using the table, find the inspection charge and the hourly fee. Okay, so in this case, let's go through and let's do our steps to find the equation, right? Because if we find the equation, we can know the cost and the hourly fee. Now let's talk about, how can we relate cost and hourly fee to what we just talked about? How are these things related? Well, the thing is, the inspection charge is just a one-time cost, right? That's like the y-intercept or the b value because it's only tacked on once, right? You just pay it once for the whole repair. And then it's also additional money per hour, right? So per amount of slope, right? How much money per, sorry, not slope, per number of hours, which is like our x coordinate or our time, right? And so however many hours we're taking up, we are charged an additional amount for those. So basically, we're paying the inspection cost no matter what. We're paying B, plus we're also paying the hourly rate times the number of hours that are there, right? So we need to figure out the hourly rate, which is our slope, which is M, and also our B value, which is our cost, right? Our initial cost for just the inspection charge, right? Because that's how it works, right? They charge you once just to come and inspect, so that's B, and then they charge you every hour after that, right? They charge you by the hour as well. Okay, so let's go ahead and do that. So what's our first step is to find the slope. So what is M? M is going to be delta y over delta x. So that means we have for x, we have 6 minus 2, because this is like our x and this is like our y. And then over here, we have 385 minus 145. So let's go ahead and do that. So 385 minus 145 is 240. So we'll get 240 over 4, which I believe should be 60. So therefore, their hourly rate is $60, right? Because it's 60 times X, or times H in this case. So $60 times the number of hours. So if they work 10 hours, well, then we have to pay that $60 for all the 10 hours, right? So $600 for that, right? If it's a 10-hour job. And that might seem like a high hourly rate. However, in terms of repairing things, like appliances, stuff like that, that seems pretty fair. That's a pretty normal rate to do things like that. All right, so with that all said, now how do we find the b value? Well, we know that y equals mx plus b, and we know that m is 60, so now we just have to find b. So I'm going to plug in one of these numbers. I'm actually going to sub in to 145 in this situation, just because it's easiest. However, you can put in any number and you will get the same answer that I get here, because again, this is a linear equation. It's a line where, no matter what we do, we're still always on the same exact line. Good. So here we have 145 equals 60 times 2 plus b. So that's 145 is equal to 120 plus b, which means b is equal to 25. So there we go. So therefore, what is our equation? Is going to be y equals 60x plus b, which is 25. So actually, let's replace that with 25. So what does that mean? That means that we have to pay 25 bucks no matter what. So that must be the inspection charge. And it's, in addition to that, it's $60 per hour that it takes them, right? So even so, that way, if you bring in your thing and then it turns out, oh, the cost is going to be too high, I don't want to repair it, you still have to pay $25, right? Just for the inspection charge. So it's $25 to have whatever the problem is be inspected, and then there's after that, it's how much it's going to cost to actually repair it. So let's do that. Let's write a little conclusion sentence that just talks about that briefly. The hourly rate is $60 per hour. I guess that's kind of redundant to say the hourly rate is $60 per hour. So we'll just say the hourly rate is $60, and the initial inspection fee is $25. Good. All right, let's use this one here. Abigail buys a prepaid card for her cell phone. When she talks on her phone, a fee per minute is deducted from the value of the prepaid card. The table below shows information about the remaining value of the card. Write the equation represents a relationship between the total value, between the remaining value and the total number of minutes used. So same thing here. This is like our x coordinate, and this is our y coordinate, right? And so what we need to do is we need to figure out the equation. Now, how can we do that? Well, we don't have the slope, but we do have 2 points. And when we have 2 points, we can find the slope. So what is our slope? Our slope is going to be 12.5 minus 26.75 over 80 minus 23. Okay. So that's going to be negative 14.25 over 80 minus 23, which is 57, which is actually negative a quarter. So there we go. There is our slope. Now, what about our y-intercept, b? Let's figure that out. We know that y equals mx, which is, in this case, is negative a quarter x plus b. Okay? So the next part here is going to be 26.75 for y, and I'm going to use 23 for x. Now, again, it doesn't matter which one of these points you use whatsoever. As long as you just choose a point and stick with it, you'll be good. So that's going to be negative 5.75 plus b equals 26.75 over here. And then we add 5.75 to both sides. And we end up with b equals 32.5. Awesome. So therefore what? Well, therefore, the equation would be y equals negative a quarter x plus 32.5. So sounds like 32.5 minutes was the total minutes at the beginning after nothing was used. And then after every minute, it goes down by negative a quarter or 25 cents, right? So we could even rewrite this if we wanted and say v, the value, is equal to negative 0.25x. So we lose 25 cents for every minute that we talk, right? Plus 32.5 because initially we had 32.5, right? So if we wanted to write this using the variables they've selected, we would write it this way. But just know that it's the same thing as x and y. And this is what trips people up is they will think, oh, it's t and v. We didn't learn about t and v. We just learned about x and y. Well, consider that it's the same thing. It's the same method either way. It's still a linear equation, even though we're just switching y for v and x for t in this case. It's still good because even though it doesn't look like y equals mx plus b, well, if y is v and x is t, then yes, it does, right? Then once again, yes, it does. It's still that same structure, right? There's not any square roots or squares or anything like that, or fractions with our variables, that sort of thing. That's not really what's there, right? But yeah, there we go. That is it for today. Good work today, everybody. I hope this was a good introduction for you for this unit, and we will see you back for the next day. Good work, everybody, and goodbye for now.